All right, so the trapezoidal rule is the following. So if we can't find the antiderivative of a function easily, we may want to try this rule, and that's called the trapezoidal rule. It's an efficient method to estimate the area when we cannot find the antiderivative. So again, you may not remember this area. 1/2, you add up the two base and then times by the height. So example 1. Approximate the area under the curve f of x equals x squared on the interval 1, 2 using 4 equal subintervals using the trapezoidal method. Compare your answer to the actual integral. Okay, so we're going to actually draw this. Okay, so do you remember what that looks like? Oh, I should hope so. You spent all of grade 11 doing parabolas, right? 0, 0, 1, 1, 1, 2, 4, something like that. Right, and then on the other side. So then what does this look like? We have from, here's 2, here's 1. And we have to divide it into 4 equal subintervals. So what we have to do is we subtract the upper minus the lower and divide by how many there are. So that would be the change of x is 2 minus 1 divided by 4, which gives me 1/4. So that means we're going up by 1/4. So I'm going to obviously this is not drawn to scale. I might even blow this up even more. Really doesn't matter. If I were to blow this up better with GeoGebra, you'll see that, yeah, GeoGebra.
If you bring up the quarters, you have one extra line.
I have an extra line?
Oh,
What
wait, no, you don't.
No.
This looks weird.
It does look weird. Okay, so this is a little bit better drawing. Sorry if you won't have this. So, so do you see if I have, here is 2 and here is 1, yes? And then if I split it in half, 1, 2, 3, 4, 5, of course this is in fifths. That's okay. So split it in half, split it in half, split it in half. Okay, again, mine's going to be rough anyways. So do you see if you were to zoom in on this, this kind of looks like trapezoids, doesn't it? It looks like trapezoids like this, right? Do you see? Kind of like trapezoids. A trapezoid that looks like this. Trapezoid only has to have one set of parallel sides. That's the only qualification for it. Yeah, whereas a parallelogram has 2 sets of parallel sides. So do you see, here's my parallel sides here, right? This does not have to be parallel to that, and they don't have to be going in opposite directions like this is. You can have a trapezoid that looks like that. However, if it starts going this way, you might think it's a parallelogram if it's parallel. So, anyways, we need to find now the area. So, what are we going to do? Well, we need to add up all the areas, right? So, what is the width each time again? 1/4. So, do you remember the formula for area of a trapezoid? You need to take the base 1 and add base 2 to it, right? So base 1 is this one, base 2 is this one. Maybe I'll use different colored pens so you can see properly. Here's base 1 and here's base 2 in the first trapezoid. Here, I'll write it here, base 1, base 2. Of course, this is the height. The height and the bases have to be at 90 degrees. And it just so happens that it's one of the side as well. Okay. So my area then would be The first width is 1/4 times. I got to add up to the two bases. So what's the first height of base 1 here? 1 plus, oops, why does I have a plus plus? 1 plus, what do you mean 25/16? Oh yeah, so does everybody know what each one is? So if this is 1.5, so this would be 3/2. What's halfway between that? 1.25, which would be 5/4, right? So this would be, what would the height be here? 25/16, right? Okay, and then the height is that, right? So we need to also divide it, times it by 1/2. I could put the half there or that. Okay, that would make you feel better. 1/2, 1 plus 25/16 times 1/4. That's the first trapezoid. Plus 1/2, what's the next one? Well, this now becomes base 1, this becomes base 2. So what's that height? 9/4. So base 1 would be 25/16 plus 9/4 times the height, which is 1/4. Yes? Plus, yeah, we would use a calculator. Next one, 1/2. Remember, we have to have 4 we add up, right? So the next one would be 9/4 plus, what's this one here? 1 3/4, so that would be 7/4. So that would be 49/16, yes? And then that would be times the width, or the height is 1/4. And then our last one would be 1/2, 49/16 plus, not 2, 4, yeah, times 1/4. Okay, so do you notice a trend or what's going on here? Like that we could have simplified things a little bit here? The 1/2 is common to all of them. And the height is always the same.
And the denominator.
So I'm going to show you, if I factor out the 1/2 and the 1/4 from everything, guess what I get?
Yes, good numbers.
I get some good numbers. You'll see a trend going on here. So I'm going to factor out the 1/2 and I'm going to factor out the 1/4. I could have just done 1/8. Okay? What am I left here? I'm left with 1 plus 25/16 plus, what am I left with here? 25/16 plus 9/4 plus, what am I left with here? 9/4 plus 49/16 plus 49/16 plus 4. Do you see another trend going on here?
There's 2 of everyone in the middle.
There's 2 of everyone in the middle here. Do you see that? So this will actually simplify things a lot, right? So anyways, let's calculate it. Let's get out our calculator and calculate it all.
Wait, what do you do?
I need. Anybody have an answer? Remember I said the shortcut is I see two of them, so I'm just adding two of them up. It's just a little faster. I snuck it in. 2 point, I have 34375. Did anybody get some? Josh doesn't have that.
No, I might have done something wrong.
Anybody verify this?
Yeah.
Okay, good. Now let's do the actual fundamental theorem of calculus. We're going to do the integral from 1 to 2 of x squared dx. So what's the antiderivative of x squared? 1/3 x cubed from 1 to 2. Plug her into the fundamental theorem, and we get 1/3 times 2 cubed minus 1/3 times 1 cubed. And guess what you get? .3 repeating? Very close to that, hey? Do you remember when we did the rectangles? We weren't very close to the actual. It was close, but not really close. This is very close. Do you see how close this is? Very close for being an estimate here. So we're going to do the same thing, and we're going to find the actual area using FTC. So because this is the square root of x, and we're going from 0 to 4, what would the integral be? 0 to 4 of the square root of x dx, which is also the same thing as 0 to 4 of x to the power a half dx. So add 1 to 1/2, we get 1 and 1/2, 3 over 2. So this would be 2 over 3 x to the power 3 over 2, yes? From 0 to 4. So this is 2/3 times 4 to the power 3 over 2, subtract 2/3, 0 to the power 3 over 2. So really it's just that. So does everybody see with 4 to the power 3 over 2 that you should square root it first, which would be 2, and then 2 to the power 3 is 8, and then 8 times 2/3 is 16/3. Yes? Did I do that too fast? Square root of 4 is 2. 2 to the power 3 is 8. 8 times 2 is 16 over 3. Yes? All right. So, and I'm going to do it as decimal. So that 3 goes into that 5.3 repeating, just so you know. Okay, so now we're going to use LRAM. LRAM. Remember LRAM? This is RRAM, just so we can see how bad it is, I guess. So we're going to split it into 4 rectangles here. So do you remember how this works? If we're using LRAM, we're going from the left-hand side. So this rectangle is 0. This rectangle is that. This rectangle is that. And this rectangle is that. Yes? Not very efficient. Yes? So this is 0 plus, this is a width of 1, so 1 times, what's this height here? 1 plus 1 times, what's this height here? Square root of 2 plus, what's this height here? Square root of 3. So we get, punch her in. Approximately 4.14626. Yes? Okay. Then we're going to do RM. So the width is 1. 1 times the height is 1 plus, what's this height? Square root of 2 plus, what's this height? Square root of 3 plus, what's this height? 2. Do you guys notice if you've done some of the worksheets that have tables, that the left rectangles, you just shift the 4 to the left in the table, and the right, you just shift to the right? Like if you've done those worksheets, you know exactly what I'm talking about, right? Yeah. So approximate, and that's how the exam will ask you, is in those table forms for sure. It's hardly ever they get you to draw it. They have asked you to draw it in the past just to show that you know how to do that. So then you get 6.146 blah blah blah. So guess what happens if I want you to take the LRAM plus the RRAM and divide that by 2, just to get an average of the two.
Is this for D you're talking about?
Yeah, that's for D. Do I not have it on? Yeah. Did you get roughly 5.1462? Yeah? Okay. Now we're going to do the trapezoidal, and we're going to discover something kind of whatever. So remember the trapezoidal. What was the trapezoidal again, the formula? A half times the width, which is...
Oh, you're talking about actual numbers?
No, remember I did the shortcut up here? Does everybody see what I did up there? Back here, I shortcutted this by saying, remember we had 2 of the middle terms and 1 of each end term? And so it was 1/2 times the width times all those added up. So that's what I'm going to try to do here. 1/2 times the width times the first one once. So that's 0. Plus twice the second one. What's the second one? I'm going to put 2 times 1 just so you know what I'm doing. Plus 2 times, what's the second one?
Root 2.
Root 2. Plus twice the third one. Root 3. Plus once of the last one, which is 2. So let's add her all up. .1462. Does that number sound familiar? Oh, it kind of does. Look at that. It's the average between LRAM and RRAM. But does that make sense to you that would work the way it is? If you think about the table thing that I was talking about, the lefts you're shifting 4 to the left, and the rights you're shifting 4 to the right. So we only count the ends once, and we have 2 of the middle ones, right? Okay.
This is the last lesson of this unit.
So what do you notice?
I noticed that this lesson
Yeah. Okay, and so this is basically what I already proved to you. It looks all fancy, but essentially what we're doing is we're taking 1/2 times the heights. What the heights are the widths of each sub-interval. And we're taking the end ones only once, and all the middle ones we're doubling it, right? Again, I showed it to you here. when I factored out the 1/2 and the quarter that was common to all of them, you notice that you're adding up 1 plus, and then all of a sudden you get 2 of them, 2 of them, 2 of them, right? So then I simplified it by saying I have 1 of the first, 1 of the last, and I have 2 of all the ones in the middle. So that's why we have 2 of them. And it should make sense to you if you think about how a trapezoid works. We're taking this one and this one, adding it up, and then the next one, it's this one and this one. You know what I mean? So we have 2 of them now. All right. So, when is a trapezoidal rule an overestimate or an underestimate?
Oh, no, this is over. I'm being confused, but they're so close together.
Okay, so this one is an under. This is a over. This is a under. This is a over. So what do you notice?
Concave up is...
Yeah, concave up is over, and concave down is underestimating. Yes? Okay, so now I'm going to show you a table, I think. This is a calculator allowed one. It says, you could, yeah, because you just shift it, right? If you do that one worksheet, you'll know what I'm talking about. The one that says Riemann's sum, or who's Riemann, or something like that. Okay, so it says the temperature in degrees Celsius of a water in a pond is differentiable function W of time t. The table shows the water temperature as recorded every 3 days over a 15-day period. So notice that for your independent variable, it's going up by an equal amount. Now on the worksheet I'm talking about, there was some that went up by an equal amount, and then there was some that went up by an unequal amount, and that's how it is on the exam. Okay? So it says use data from the table to find an approximation for W prime of 12. Show the computations that lead to your answer.
No, it's not W.
Okay, so now we got to think back to the beginning. What does W prime of 12 mean? That's the derivative. And how do we find the derivative? This is an actual AP exam question, by the way. How do we find the derivative? Calculating the slope of a secant line, right? Well, of a tangent line, but that means we'd have to have way more information to actually do this. So in this case, we're doing a secant line, right? So then you might say, well, what points do I use here?
First and last.
So,
I don't bet MVT wins.
so, okay, so I heard, let's use the first and the last. To find the slope of the tangent line right here, would the first and the last be a pretty good approximation?
Oh, wait, no, never mind.
What do you yeah, you need to narrow it down a little bit closer. So how about we use 9 and 15 there? Okay? So how do we find slope again? Yeah, y2 minus y1 over x2 minus x1. Does everybody see this? So 21 minus 24 over 15 minus 9. Everybody good with how I'm getting that? So then I get minus 3 over 15 minus 9 is 6, so I get negative a half. And, oh, it says indicate units. What would that be? You guys, it has units right here. What did I have? Yeah, but what's on top? Not days. Celsius. Degrees Celsius per day.
Yeah.
Okay, it says approximate the average temperature in degrees Celsius of the water over the time interval 0 to 15 by using a trapezoidal approximation with subintervals of change of time equals 3 days. All right. Do you see in here it says average temperature? What did we remember about average? Some of you have done, oh, there's a formula. Yeah, so average is equals 1 over b minus a times the integral from a to b of some f of x dx, right? This you should have in your back pocket somewhere, okay? Anytime you see average, you don't just find the area, you have to divide or multiply by 1 minus b minus a. So we have to use the trapezoid approximation to do this part of it. This is the part we're using the trapezoidal approximation for. F of x dx. F of x dx. So let's do the trapezoidal first. All right. So what was the so we're going to say area is equal to 1/2. All the widths are the same, so we can pull out the 3. And then trapezoidal means we add up one of the first one, so 20, plus double the second. Do you want to just do 62? No. Oh, okay. 2 times 31 plus 2 times 28 plus 2 times 24 plus 2 times 22 plus 21. Okay, so I'll give you a second to add her all up. Remember, we want to save time eventually when we write this exam, right? Did you get 376.5? So then my average is going to be 1 over, what's b minus a? 15 times 376.5. So basically that divided by 15. So 25.1. And that would be what? What would the units be?
Degrees Celsius.
Degrees Celsius, yeah. So that's the average temperature in degrees Celsius. It actually says that right there. All right, next one says a student proposes the function p given by p of t equals 20 plus 10 t times e to the power minus t over 3 as a model for the temperature of the water in a pond. Blah, 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 blah. Okay, so it says find p prime of 12. Okay, let's do it. By the way, we can use a calculator for this. Has anybody figured out how to use the derivative part of their calculator?
Let's see.
Yeah, it's in calc.
Well, it'll be in catalog.
Oh, look at that.
So I'm going to get my calculator just so you know. You can put that directly in. Here we go. So we're going to go to math. And mine's number 8. Is that what everybody else is? Is 8. And then, do you guys have a fancy thing, or does yours look like mine at this point? Yours is fancy?
Fancy.
Okay, 20. I have to do it the old-fashioned way. 20, but I know there's somebody else in this room that has to do it the old-fashioned way. Plus 20t e to the power minus t divided by 3 bracket, comma. Do you want me to do it a little further down so you can see what I'm doing?
How do you do two variables?
There's no two variables in there. What are you talking about? Comma 12. No, I have the old-fashioned one.
Can you show how to do that?
Okay, so just so you guys know, on the AP exam, you can't write this and expect to get full. You'll have to do P prime of 12 equals negative 0.54946, and that would be degrees centimeters. Again, Celsius per day. Remember, derivative is slope. Slope is the rate of change, so it has to be per something, right? Okay, redo part B using the function in part C.
Ooh, so we needed a function.
So they give you the function now. So does everybody see? This is the integral from 0 to 15 of 20 plus 10t e to the power minus t over 3. We're going to say it's dt, right? And of course, this is 1 over 15 times it, right? So if you were to, so here's how you save time on the AP exam. If you would have punched, if you knew that you, okay, I'll repeat or restart. If you know you have to use this equation more than once, it's faster to type it into y1. And then when you're typing this, just use y1. And I'll show you what I mean. I'll show you what I mean. I'll show you what I mean. So do you see y1 here? If you would have typed in the equation 20 plus, again, it's all about saving time here, people. E to the power negative x divided by 3. Okay, so then once you have this in y1, you can just refer to it as y1. Meaning, in your calc feature, in my math calc,
Oh, it gives you the integral for.
yeah, you can do. Oh shoot, let's get out of there. I need to quit out of there. So now I'm going to do the same thing again. I'm going to go to math 8. And instead of typing 20 plus 10 blah, 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 I'm going to type y1. And you might say, well, where the heck is y1? You got to be told this once and remember this. It's vars, toggle over to y vars, press function 1, and there's your y1. So I'll repeat. It's vars, y vars, function, and then there's y1. Okay, so then I have y1, and then I'm going to do comma x, comma 12, and then I get the same answer that I did the other way. Why would I do this? Because in C, I need to do the same thing again with that equation, but as an integral, so this will save time in the end. And you might say, well, no, it doesn't really. I'm pretty fast at typing. Whatever. I'm just trying to give you an option here, okay? So math, the function of the integral, right? And it is vars, y vars, function of y1, comma, x, comma, the upper, which is 15, whoops, and the lower. Get your answer, divide by 15, because that's what we have to do to find that. And you get negative that.
What is that?
That is my real answer. Like the one I did up here was my trapezoidal answer, 25.1 degree, right? This was,
I got a positive question.
oh, did I screw up somewhere? Oh, you know what? I think I was supposed to go 0 to 15. Sorry about that. I screwed up. I'll try that again. Try that again.
So what is F into? What is F into?
So this is 0, comma. Yeah, no, that's why your guys' calculator is better, because it'll automatically put it in the right way, right? So just something, food for thought, you know. Just showing you some more features on your calculator. 757 degrees Celsius. Now we're going to go to a multiple choice AP question. By the way, this is on the calculator part of the AP test. It says calculate the approximate area of the shaded region in the figure by the trapezoidal rule with divisions of x equals 4 over 3 and 5 over 3. So, what's my first, like what would I be typing? Like you get a calculator, however, you have to know what to put in here, right? So the area would be 1/2, because that's part of the trapezoidal formula, right? And what is the height or the width of the x's? 1/3. And then I'm adding up the first y value. What's my first y value? 1 plus, what's my second y value? Not 2. That's my last. Actually, it's not even my last one. My last one's 4. Remember, we're cutting this into. No, it's saying it's 4/3 and 5/3 there. So it'd be 2 times 16 over 9 plus 2 times 25 over 9 plus 4. Okay, so I'll punch her in. Everybody knows how to change your decimal into a fraction, right?
Actually, I learned that in chemistry. Yeah.
Well, 4/3 is 1 1/3, and 5/3 is 1 2/3. So just by inspection, I know it's going up by 1/3, right? Yes? Times 1, oops. Bracket 1 plus 2 times 16 over 9 plus 2 times 25 over 9. Did you guys get that? You go frac. Math frac. So when you do it on your calculator, you punch this all in, you get a decimal, then you have to go to math, and then the first option is frac, go enter, bam, there's your answer.
Yeah, no one ever told us that for the longest time.
I thought I told you that yet last year. Yes, I did. Okay. I did, see? Well, because Crystal's the only one that listens to me. And this is on recording now, Crystal, so you're ever famous here. Okay, last example. Here's a table of now this time, this is what I'm saying about, does everybody see it's going up by 1. It's going up by 4. It's going up by 1. It's going up by 2. We cannot do the widths evenly now. We cannot just put in, like we did the last one, 1/3 was the width. So it's first off, it says write an integral expression in terms of t of x for the average temperature of the wire. So it's going from 0 to 8. So what would the average temperature be? 1 over 8 minus 0, so 8, times the integral from 0 to 8 of the function t of x dx. Okay? So now we're going to estimate. For some reason, that's an easy mark if you know what to do on the exam, right? Yeah, they actually asked you that. Okay, so now we're going to estimate the average temperature by finding the trapezoidal sums with the 4 intervals. So, average is going to be 1/8 times. Now, how do you find the trapezoidal thing? It's 1/2. Now we can't do the width this time, right? Because the widths are all different. So now this is going to be, what's the width here? 1. Now, times, we have to take these two. Remember, we can't do the double, and we can't like split it up like that. So the width is 1, and we have to add up the two things. No, the 0 is the x. So 193 plus, what's the width here? 4. And then we have to add up 93 and 70. So what's that? 163 plus, what's the width here? 1. And this is 132 plus 2 times, what's the width here? 117? Holy. Okay. So now we have to add them all. You don't have to what? Okay, the only reason that trapezoidal rule works with double the middle, and it's because they're all equal intervals. Now we have to do this all separately, right? So 1/2 times the two bases added up times the height. The height is the width, but the widths are all uneven. That's why we have to do them all individually, right?
The interruption with the following students, please come to the office. Dario Pokrak, Matthew Kwiatkowski, Emma Friesen, and Tanya Koyoki. Please come to the office.
So did you get 75.86875, and that would be degrees Celsius, right? Degrees Celsius. This is, here I'll write it a little better here. 75.6875 degrees Celsius.